Welcome back to my YouTube channel. Today I'm talking about C-score. Okay, so a C-score is a standardized score. And what we mean by that is if you repeat this process many times with different data sets, you will always end up with a set of values with a mean of equal to 0 and a standard deviation equal to 1. So that's the standardization. The scores will have mean equal to 0 and standard deviation equal to 1, and that has some good property for getting proportions of the data. Okay, so let's talk about what's going on here. So we take each value and subtract the mean of the data set and divide by the standard deviation. So what we're actually doing is we're taking the prior mean of the data set and we're subtracting it from each value. And that process in itself is making the mean of the data set equal to 0. It's canceling out the prior mean and making the mean 0. And when we divide by the standard deviation of the data set, we're doing the analogous thing of setting the standard deviation equal to 1. So that's essentially what we're doing. We're just transforming the values to have a predefined mean and standard deviation. And like I said, that has a useful properties that we often use in, honestly, introductory stat classes. I don't normally calculate C-scores. I do often standardize data when I need to do special things, but even that's uncommon. And what I'm really talking about is sometimes you need to standardize data when you put it into a neural network, but that's far removed from this. Okay. So when the C-score equals 0, the value is attacked at the mean of the distribution. When it's greater than 0, it's above the mean. When it's less than 0, it's below the mean. And a C-score greater than 2 or less than -2 is often considered unusual. And we're assuming an underlying normal distribution in the values for these proportions. If the data you're using is not normally distributed, you have no reason to believe that it will be after you do this transformation. But assuming it's normally distributed, you have these properties. So you can get proportions. You can look it up on a C table and see what proportions between 1 and 2 and everything like that. Of course, you can now use online calculators, so that's more of a learning exercise than a practical thing. You can find outliers. That'd be fairly easy to do. I would use 3 and -3 to find outliers, because 2 and -2, it's still going to classify at 5% of your data as outliers, where -3 and 3 would, I believe, be 99.7%. It would capture 99.7% of your data, so it would be like 0.3% outliers. But that cutoff it's arbitrary. Oh yeah, 99.7. Found it right here. Fantastic. Okay. Yes, so probability calculation, that's what I'm talking about with proportions. And yeah, it's the basis of the C test, but no one actually uses that test. I mean, that's not true. People use it for certain thing, but practically, you're not going to use it. Yeah. Okay. Now that I just gave my hot take about statistics, the standard normal distribution, which is made by the Z-score, assuming the underlying distribution was normal, what we're going to do. 68% of the values fall within one standard deviation, so negative 1 and 1, 95, 2 standard deviations, and 99.7, 3 standard deviations. Okay, so I picked this example because it's an example of an IQ test. IQ tests are made to have a mean of 100 and a standard deviation of 15. So if you got an IQ score of 130, you would do 130 minus 100, which would be 30, and divide that by 15, and you'd get a Z-score of 2. And that would mean that it's 2 standard deviations above the mean of the data set, and quite high in percentile. Okay. So yeah, you can use Z-scores to find outliers. That might be one of the more useful things. And the basis of some hypothesis test. And honestly, it's not a standardized score. You can standardize data in all sorts of ways. This is just one way of doing it. And it happens to correspond with a standard normal, which historically statisticians have cared about. They put a lot of effort into understanding it. Okay, so that's the end of the video. Thank you for watching.